Hello, welcome back. In our last video, we talked about what is a limit. And what I would like to take a look at right now is this row right here. Now, notice in the first example, we said the limit from the left, we said is approaching 2, as well as the limit from the right. It was also approaching 2. So we said that the actual limit itself also has to be 2. So what I want to ask you guys a question right now, real quickly. Well, what is the value at -3? And to get that, the value, so if we're looking at -3, we said that the value here is 5. And so we can write that out here. We can say that the value at -3 is 5. And that brings us an interesting problem. We can start talking about something called continuity. Continuity, we have a limit, which in this case was equal to 2, and we have a value which is equal to 5. So what that says is I'm approaching 2, but the value itself is at 5. That's like if your friends tell you, hey, we're at a party and you're approaching the wrong house, but the party's at another house. So they gave you the wrong address. That reminds me of my high school days. But I digress. So what we want to do ideally is we want to make sure that the value here at 5 is the same as the limit itself in calculus. So in calculus, what we want is we want this value, and here's my limit. Ideally, we want them to be the same, and we have a special name for that. If the value of the function is equal to the limit, so if that value equals limit, we call that function at that point. Now notice, only at that particular point, we call that function continuous. Now we're going to spend a lot more time with this later on. Continuous. There we go. We call it continuous. So we can say is, whoops, sorry, can't spell the word is today, is x equals 3 continuous? That should be -3. There we go. Is x equals -3 continuous? And the answer, of course, is no. The value we're approaching 2, but the value is 5. So we would say no to that. But let's take a look. What about x equals 0? So let's look at x equals 0 now. Well, if we look here at x equals 0, our line is approaching -2, and the value is also -2. So I'm approaching what the value is. So at x equals 0, the answer would be yes. And we're going to say simply because that the limit is the same as the value. Very easy to do. All right, so we like continuity because if we know a function is continuous, we can actually just substitute in. So if we know that that a function is continuous, we can substitute x to get the limit. First, you want to check for any domain restrictions, okay? Remember, domain restrictions are very simple. You cannot divide by 0. No division by 0. And no negatives under an even root. You can't take the square root of negative, like you can't. We don't want to deal with imaginaries right now. That becomes too complex for us. Ba-dum, thank you. So if I take a look right here at the first example, I got x squared minus 3. Well, we know what x squared minus 3 looks like. It's just a parabola. Now, a parabola, does a parabola have any holes, gaps, asymptotes? That's really what we're looking for. So when we talk about continuity, we're really talking no holes, no gaps, no jumps. We'll talk about those, and definitely no asymptotes, like mainly vertical asymptotes. Asymptotes. There we go. No asymptote. We can't have any of those. Parabolas don't have any of that. So we know a parabola can be considered continuous. So as a result, my rule says I can just substitute this in. And that's going to give me just 2 squared minus 3, which is just 1. So in other words here, that the limit, we say, approaches the value. We can actually just say that. Then in this case, the limit actually approaches the value because f of x is continuous. We like continuity. All right, so let's take a look here. Oh no, here we have a rational. Well, I know x can't be -4. That's a vertical asymptote. And remember, for continuity, we don't want vertical asymptotes. But it doesn't mean we can't solve it because we're only looking at x equals 0. Since 0 is not equal to -4, we can assume it's continuous at 0. You get what we're doing here? We can assume continuous as long as it's not a domain restriction. So if I plug in 0, we would get 0 minus 3 over 0 plus 4, which is -3/4. All right, let's commit a sin. Sine of x, a very simple one to work with. Okay, so for sine of x again, sine of x, it's continuous everywhere. So so let's take it. So we can just plug it in. We would get the sine of pi over 3. And the sine of pi over 3, very simple, is √3/2. All right. We can even do weird things with infinities at this point. Ready? Infinity's kind of a weird thing. So we're not going to mess too much with it yet. We'll talk more about that next week later on. But with infinity, it's really simple. We can just kind of imagine. Infinity, you can just imagine. Like if you take infinity and you plug it in, you square it like infinity squared minus 3 times infinity. It looks like it's just going to be infinity minus infinity. But we can't really think of it that way. Because if you take a big number and you square it, it's a lot more than if you just take 3 times that number. Like, for example, if you take 100 and square it, that's a lot larger. Like, if I took 100 and squared it, that's a lot larger than 3 times 100. So, we start this idea about infinity that not all infinities are equal. And so I kind of have a little rule for us that infinity does not equal infinity. We just have to think about, well, what matters really the most? And if I think about what matters the most here, infinity squared matters a lot more than 3 times infinity. In other words, a parabola grows a lot quicker than a line. So I really don't have to worry about that 3x. And I could just plug this in, and I would get infinity squared, which is positive infinity. Very easy to work with. But oh, this one's free. Ready? What if we did the limit as x approaches infinity of 3x minus x squared? Well, now take a look. Again, that 3x doesn't matter as much as that parabola right there. It just matters so much more. But if I plug it in now, be careful, I'm going to get this negative infinity squared, and I will get negative infinity. So we tend to say that this actually decreases without bounds. And if we think about it, 3x minus x squared is a parabola that opens down. And as we go, as x approaches infinity, we are getting more and more negative, and it kind of shows that in behavior right there. All right, so let's try a fancy one. Let's plug in 0. If I just plug in 0, let's try this one here. If I plug in 0 to the top, I get the natural log of 0 plus 3 over 2 to the 0. Oh no, you got to remember this stuff. On top, I get the natural log of 3, and 2 to the 0 is just 1. So there's our answer. All right, so I hope you enjoyed the video here. If you had fun, please like, smash that like button, subscribe. I'll see y'all later. Bye-bye.